Okay, so for the next one, forgive me if I move a little bit fast, because I think that it's kind of just a lot of rehashing, but some restructuring of what we've already done. Essentially, what I'm going to be doing is extruding the curve in the same direction that I extruded basically these, right? So the first extrusion was vertical though, and so with these ones I'm going to have to extrude it in the opposite direction of where they are in space. And so I can do this a couple different ways. I can find a surface normal to use it for. I could map a perpendicular frame, and then I could use one of those axes to kind of do the angular extrusion. I could create a surface and then offset both sides and then trim it out and do all that other roundabout stuff. But I think now that I'm already operating with perpendicular frames, one of the easiest ways for me to move forward with this one is to again use perpendicular frames. So let's keep practicing with that. So what I'm going to do here is I'm going to borrow the perpendicular frame and the 0.5 param, and I'm going to pull this down here, and I'm going to replace the origin bias curves in the input there. And so here you're getting a sense of, I think you're getting a great sense of how you can start to map really interesting and intriguing geometries in space with these kind of structural forms. So perpendicular frame will give us the opportunity to grab one of these axes in order to extrude. And in fact, because our extrusions are perpendicular in nature, it actually gives us both of our axes that we need to extrude. Easy. So this is how I'm going to do this. I'm going to kind of grab what I want to do and work backwards. So what I want to do first is extrude. So let me grab my extrude tool. I'll go to surface and freeform and extrude. And it's going to ask for the geometry curve to extrude and the direction. So the direction is the harder part here because I'm going to be extruding from one of the axes of these frames. But first I have to grab that axis. So under vector, I think it was, and plane, I can do deconstruct plane. So now deconstruct plane, when I plug that in, it takes these frames that have 3 axes and it breaks it down into its origin position, the x direction and the y direction and the z direction for all of these perpendicular frames, all of them. So that way I'm generating all, is it 7 in this case? Yeah, all seven extrusion directions that I need. And I'm just going to give it a static number and it'll apply it to all 7 of them. So that's my direction component. I then need to establish the magnitude component, and that'll be done using the same thing we've been using a lot of, and that's the amplitude. So looking at the frame here, if I want to start off my extrusion going in the direction of the entire truss, right? I guess I can start that way. It doesn't really matter because it's going to go either way. But I would want to use the green axis. So that's going to be my y-axis. So I'll plug that into my vector input. And then I'm going to need a magnitude. So I can do something slightly different than the thickness that I used if I choose to. For the top and bottom chord, and I'll make it half of the thickness. Just throwing that out there. It doesn't have to be. So I'll do... did I use a slider or a static number? I use this. In fact, we could actually just borrow this because... Oh, wait, hang on. My extrusions were up here, right? Hang on a moment. Oh, that is my extrude. Okay, never mind. We can use this. Oh, no. Sorry. This is what I want. I totally lied. So this is the one I want right here. So I will copy, paste, and pull this down. And in fact, you can copy and paste this one and pull that down as well. And so this one, I'm going to use the same value for both. And the term in a structural truss for the members in between, did I call it web? I don't know if they call it web in a truss. I don't know. Anyway, just call it, I don't want to call it web now for fear of sounding foolish. Just call it vertical thickness. And you can change this one again, vertical thickness, and make sure you connect them. Just double check that these are connected. And then the vertical thickness is going to get plugged into amplitude. The negative value of the vertical thickness is going to get plugged into amplitude. And that will be our D. And the curve is our B. Interesting. It only went one direction. That's weird. Oh, because they're going opposite directions. Why would they be going opposite directions? Oh, I know why. Okay, so here's what's happening. So the reason that it's not doing both of them at the same time, although it should, and it should still do it in both directions, I think it's because this is facing the opposite direction than the other surface. So see how this is more red and this one is darker? So they're facing two opposite directions, so for some reason it doesn't want to create both surfaces at once.
Can you show me everything on Grasshopper? Okay.
Let's see. Okay, so in order to correct this, you guys remember the perforations example that we did, where we moved the curve off the surface and then we extruded the curve through, and we used that extrusion as our cutting element for a warped surface. So we're going to do a similar principle here, just to be sure that our surfaces are all facing the same way. So I'm going to insert a move command before I do the extrude command. So I'll go to transform and Euclidean and move. And I'm going to, you can leave everything else here because it's all going to be relevant, but I'm going to move the curve, and it's going to go along this vector. And then I'm going to take that curve as my extrusion, and it's going to go along the negative vector. Oh, I need an amplify. So we'll go to vector, vector, amplitude. So this is going to be our amplitude, and this is going to be the vector as well. We'll go. It's going to look a little weird and funky. Plug that in here. And the only difference here is that this is going to have to go twice as far. So we'll take that negative x and we'll the amplitude value here, and we'll make it x times 2. There you go. That's what we want. So something that you will notice is that there are some, corner issues we'll have to clean up, and I'll go through a whole separate thing tomorrow about cleanup when we get there. But essentially, this is just one part of the extrusion. We have to do the next part of the extrusion, which is copy and paste this extrusion here. The geometry that we're now going to extrude is going to be the original extrusion. And the direction is just going to go the other way on the plane. So we used the y-axis to do the, flat plane. So we're going to use the x-axis to do the other direction. And so we're going to also need another amplify for that.
What was the expression on the amplified?
X times 2.
X.
So we're going to need another amplify for the x. So vector x, the amplitude is going to be, you can make it the same. It depends on whether or not you want it to be different or the same. In this case, I want it to be the same. Actually, yeah, I want it to be the same value as this negative. So I'm going to plug that in here. And that vector is going to be my D. Oh wait, hang on. What did I do wrong here? Oh, because that's only going one direction. I need to go, I don't want to have to do all that again. Wow, this is getting really layered. There's got to be a better way to do this. Anyway, it looks like we're going to have to do it both ways here. So, this is my -5. I need to do another one for a +5. So that's going to be copy paste, and then I'll plug +5 in. There. And that. Huh? Oh, sorry. It's only one amplitude. So we have a negative, we have a positive. There we go. Come on. Huh. Oh, wait a minute.
It's connecting on the left side on the top, and on the bottom it's connecting to the right.
Yeah. Something's different about the information, and I can't figure out what. The vectors are coming through as 7 separate vectors. This one only has one vector. So, okay. So, in this case, the vectors are coming through as 7 different vectors. So for every single one of those vertical elements, it has a separate vector. So what I overlooked is that every vector should only be paired up, or every amplify should only be paired up with one vector. So this will have to be grafted. The X output will have to be grafted. Yeah, okay. And then I believe the Y output should also be grafted, if I'm not mistaken. And it looks like I am. One vector, 2 amplitudes, gives me that, and 1 curve or surface. This is giving us 7 curves or surfaces. That needs to be 1. Okay, so I have some duplicate layering here. Give me gonna pause the video here and see if I can troubleshoot this. Okay, so what I missed here, and I reoriented this, guys, so maybe this will help you out in your own troubleshooting. What I had to do was to think through it in terms of sort of like phases. So I thought it through in terms of, here's my base information in this, you know, row or column, I should say. The XYZ axes, the numerical inputs. So that's my direction and my magnitude. Then I lined up my amplitudes, and I looked at them to ensure that the input lists matched in their format. So I know what works up here was one vector with my 2 amplitudes, which will put it in the positive and negative direction. So I went through and I made sure that they were grafted or flattened, you know, appropriately. So the vectors here, all 7 vectors in their own group, and then the amplitudes, positive, negative. Same thing down here, positive, negative. The difference between these two is that the positive and the negative are in 2 different groups for these. So then this was my extrusion for the original surface, and then this one was the extrusion of that original surface to both sides. So this was the key right here. The piece I was missing was the grafting of the move. So I kind of went forward a step here to move, and I looked at it, and I said, I noticed that all 7 of these surfaces are in a single list, and it was receiving 7 translation vectors with direction and magnitude. So what was happening was those 7 surfaces were being extruded 7 times in the same place. Okay, so I had to graft that. Okay, so let me just kind of close the book on this one real fast. And so really, at that point, we have our extrusion, which is the same as this extrusion here. So we'll have to grab our surface union and our face merge, and then we'll pull that down and plug our extrusion in, turn all of this off, and there you have your first vertical element. And you can copy and paste this whole thing down to the next level below when you're ready. Any questions? So assuming you're right on my tail with this, you've got 15 minutes left in class. I imagine we can all get the other side done, because it's really just copy, paste, plug it in. Just make sure that it's mapped to the same value. Over here, this vertical thickness, make sure that that plugs into the next one as well.